Our products are forward-looking because they are largely developed from forecast data, and we combine that with real-time Earth observation data. So we have two components that are really important in terms of forecasting. We are talking about looking at the conditions in 1 month, and we're also talking about looking at the current conditions, and which all can be gotten from satellite information and at ICPAC that we generate forecast data. For example, in desert locust prediction, we look at the forecast information, forecasted climate and weather information, the relative humidities, the rainfall, the temperatures that support locust development and migration. And then at the same time, we look at the current conditions from Earth observation data, from vegetation, how the vegetation is looking at a particular time. And by combining that, we're able to get forecasted information on where locusts are likely to breed, where they're likely to migrate. And so we prod early action by doing that, by providing early warning information. For example, last year during the peak of the locust invasion in the region, ICPAC through IGAD was coordinating desert locust control unit, and countries like Kenya had lead time information through our network. And by doing so, Kenya and Uganda were able to design their response plans, exactly the areas that locusts were coming in through. They were able to design their control plans by locating aircrafts at critical points. And in so doing, they were able to prevent locusts from really destroying, moving to crop areas early enough, and so preventing a food security disaster in the region. The East Africa Drought Watch combines key indicators that can be observed through satellite with long-term observations, what we call time series data. Long-term observations are very important because we are looking at a particular place for the last 30 years, and we are talking about every 10 days we get a new observation for the area through satellites. And in so doing, there are indicators that are developed, and the indicators help us to know the trend. Is the earth drying up? Is the soil drying up? For example, soil moisture that we are able to detect. In the crop areas, is there adequate rainfall in the crop areas? Is there adequate moisture to sustain the crops that are in the field? And in the rangelands also, are the rangelands drying up, or are they becoming wetter? And are they able to sustain the pastures there for the livestock to sustain on? So the East Africa Drought Watch really combines that to come up with the drought indicators, to look at meteorological drought, agricultural drought, and combine it early enough such that you can see areas that are starved of moisture and vegetation is drying up, and give early warning information early enough. Timely information on crop conditions is very important, and we've really been emphasizing the region network, ministries of agriculture in the region, drought monitoring organizations in the region, to provide such information, because such information we're able to tell how the crops are doing in the field at any particular time, what areas were planted in any particular season, and we blend that with satellite information that are monitoring the crop areas. And when you monitor the crop areas and you have field information, you're able to tell likely yields. You're able to look at production prospects. You can know if you will get a surplus yield, a normal yield, or below average yield. And in so doing, we're able to advise the governments that we work through, or we work for also for the regional governments, whether they'll be food sufficient or they'll have food deficits. And in so doing, they're able to act to make decisions like food importation, where to import food from. Like neighboring countries might have surplus production at any one point, and yet another country, neighboring countries, having deficits. So such decisions are what we prod by crop monitoring in the region. Crop modeling is very important, and the importance is because crop modeling enables us to know yields. Of course, there is a margin of error, but we look at key stages in a crop development. Certain crops, we can know sorghum at planting, how many hectares were planted, and how many hectares were able to germinate. We can look at sorghum against the sorghum fields in vegetative stage, in reproductive stage when it's forming the seeds, the yield, and through the harvest stage. So crop modeling is done at key stages in a crop cycle, And in so doing, we're able to sort of look at prospective yield. Will the yield be adequate because of the area planted and adequate development, or will the yield be lower than normal? So crop modeling is really important, and so because it really feeds into food security analysis. When you're talking about food security, you need to know the production, you need to know the markets, the trade. You need to know all these things also influence the prices, the current prices, future prices, and in so doing, all that information is packaged to advise on food security in the region.